Hey guys, hope you are well. So now we're going to start looking at chemical bonding. You know, your teacher's probably spoken about ionic bonding, covalent bonding, metallic bonding. Well, that's what we're going to be talking about here. And I'm quite excited to show you this because I've got some interesting ways of showing it, which from my past of teaching lots of learners in person, I was able to see that they really understood this way of explaining this topic. Okay, so what I want us to do is I want us to remember that this is a periodic table and we've got metals and non-metals. And we typically divide it by drawing this step that we've seen before. So remember, on the left-hand side of that step, so on the left-hand side, there we've got metals. And on the right-hand side, these are, okay, it's not going to help if you write it there. But on this side over here, these are your non-metals. Okay? And of course, we must always remember that hydrogen is a little bit random. Hydrogen is actually a non-metal, but for some reason, we have placed it over there on the periodic table. Okay, so what I want us to do now is I want us to take Na, for example. Okay, actually, no, we'll take lithium. And I want us to just go draw its basic structure. So we know that it always has a nucleus, okay? And we know that a nucleus has protons and neutrons. So I'm just going to put a positive charge there. Because protons are positive, neutrons are neutral. So the overall charge of the nucleus is positive. Okay, now this is for lithium. So we've learned that lithium is now in row 2. So that means it has 2 energy levels going around the nucleus. In the first energy level, so in row number 1, because to get to lithium, it's over here. So you would first have to go there and there. So that means in row number 1 there are 2 electrons. So let's go draw 2 electrons in energy level number 1. Then when you get to energy level number 2, there's 1 electron. So there. Those are the electrons in lithium, and they are negative. Remember? Okay. Now, the next thing I want us to draw is, let's go do Na, which is sodium. So, we know that it's got a nucleus, which is positively charged. Now, Na is in row 3, so it's got 3 energy levels. Whoops. So, there's 1, 2, 3. Now, we know that Na has 11 protons, and that means it has 11 electrons if it's a neutral Na with no charges and things like that. So it's going to have 11 electrons. In row 1, there would be 2 electrons. So that means 2 electrons in energy level 1. Then in row 2, there's 1, 2, 3, 4, 5, 6, 7, 8 electrons. But remember, you always put down 1 at a time in the 4 different places. Okay? And then once you've done that, then you can go pair them up. 6, 7, 8. There's the 8 electrons that it has. And then when you get to row 3, it's going to have 1 electron before we get to where it actually is on the periodic table. And so if you had to go count all of the little black dots, that would be 11 electrons. Okay. And of course, each of those are negative. I'm not going to go through all the negatives. Now, the goal. Now, this is the most important line that you could ever hear me say for bonding in grade 10. The goal of all chemistry, the reason that these electrons are moving, these atoms are moving around and they're starting to bond with each other and to react with each other, is to achieve a complete outer energy level. That is the goal of all of these atoms. That is what they are trying to do. So I know you might be looking at that and thinking, Kevin, what do you mean by that? Well, I'm still going to explain that. But right now, this atom, if you look at its outer energy level, it is not complete. How do I know that? It's not full with electrons. So if lithium would like to have a complete outer energy level, it has 2 options. But only one of them is going to be correct, and I'm going to show you that. So here's lithium at the moment, okay? It's got 1, 2, and then it's got 3 electrons, as we can see on the diagram. Now, it would like to have a complete outer energy level. This energy level on the outside is not complete. So how could we make a complete energy level? There's two options. Okay? Option 1 is going to look like this. Lithium, if lithium would like to complete this energy level number 2, then in energy level number 2 there are 1, 2, 3, 4, 5, 6, 7, 8 blocks. So that means to get all the way to having energy level number 2 complete, there would have to be 8 electrons on the outside. So that means we'd have to add another 7 electrons to lithium. Then it would look like that. And then its outer shell would be complete. But this is not correct, okay? But let's just say it anyways. Gain another 7 electrons to complete energy level 2. So that's not the way it works in real life, because that requires too much energy. And if you understand how nature works, it's based on energy. How easy is it or difficult for something to happen? So to be able to go and collect another 7 electrons is extremely challenging for lithium to do. It would rather do something else. And now I'm going to show you option number 2. So option number 2 is that we don't go collect 7 electrons like that. That's going to be too difficult. What we can rather do is, what would happen if we just decide, what would happen if this lithium atom just decides to rather get rid of this electron? Let's rather just give that one away. So we could say here, option 2 is rather get rid, or let's say give the 1 electron away. And that is so much easier to do. Rather giving 1 electron away instead of having to go collect 7. Okay? Because if it does then give away that 1 electron, then what would lithium look like? Well, lithium would then look like this. You would still have the nucleus in the middle. Whoops, different color. Your nucleus would still be in the middle like that, positively charged. Now it would only have 1 energy level, because the outer energy level is completely empty, so it's completely not even needed. And then you would still have these 2 electrons that we can see over here. And look at that. It's complete. Because in energy level number 1, how many blocks are there to be able to complete it? 1, 2. And so there are 2 electrons. And so this lithium is super happy. Why? Because the goal of all chemistry is for an atom to have a complete outer energy level. Okay, so remember that. What did lithium do? It rather, lithium chose to give 1 electron away. Okay, now we're going to quickly look at sodium. Trust me, this lesson's going to get more interesting. We're going to look at what these ones on the right-hand side do. It's going to get quite interesting. So here's Na. Remember, this was sodium, okay? And once again, you need to decide, what is it going to be better for sodium to do? We can see that the first energy level, which has 2, is completed. The second energy level, which has 8, is also completed. Okay, so the inside levels are complete. But if you look on the outer level, it only has 1 electron. If it was to be complete, it would have to have 1, 2, 3, 4, 5, 6, 7, 8. You would have to go all the way up to 8 in order to complete it. But we only have 1. Now, what is going to be easier to do? So option 1 is that Na could go and collect another 7 electrons, because it's over here now, and then it would go 1, 2, 3, 4, 5, 6, 7, and then it reaches this last column, which is where it's complete. So it could go and collect or accept another 7 electrons. Accept 7 electrons. Option 2 is that it rather decides to just give this electron away. Give 1 electron away. So what do you think it would rather do? Well done if you said option number 2. It is more easy for it to rather give 1 electron away. So let's see. Na, what did it do? Give 1 electron away. Just like lithium did. Okay, now we're going to start moving on to, now we're going to go and draw magnesium. Oh no, let's go draw beryllium. And then we're going to look at boron, carbon, NO, nitrogen, oxygen, and fluorine. We're going to see what each one would decide to do. And somewhere over here, it's going to start getting very exciting, and things that your teacher said in class are going to start making a bit of sense. Okay? It's going to really start coming together. You'll see now. Okay, so what we're going to go do now is we're going to go draw just the structure of beryllium. So we know that beryllium would have a nucleus, which is positive. And then because it's in row 2, it's going to have 2 energy levels. So energy level 1 and energy level number 2. Now, let's go fill up what beryllium already has. So beryllium has 4 protons, and so that means 4 electrons if we assume that this is a normal neutral atom. So it's got 4 electrons. In energy level number 1, it's got 2 electrons. So we can go put 2 electrons over there. And then for energy level number 2, it's going to have 2 electrons. So you always put them separate, 1, 2. So that is what beryllium currently looks like. Okay? So remember, what is its goal? The goal of all chemistry is to have a complete outer energy level. So option 1, what could beryllium do, guys? Well, it could go from here to here. So it could go 1, 2, 3, 4, 5, 6. So it could go and gain 6 electrons. Option number 2, what could it rather do? Think about that carefully. It could rather give away this one and this one. So it could rather lose 2 electrons. Now, the easiest one is going to be the one that requires the least amount of effort. So it's easier to give away 2 than to go and collect 6. So this is what beryllium would do. It would rather lose 2 electrons. So beryllium would lose 2 electrons. Next, we're going to look at boron. Okay, so we're going to look at boron, which is over here. So boron, let's go draw its nucleus. So we know that a nucleus is positive. Boron is in row or period number 2, so it's going to have 2 energy levels. So 1 and 2. Okay, now if you look at boron, it's going to have 5 electrons if it's just a normal neutral boron. So in row number 1, it's going to have 2 electrons, just like we normally see. And then in row number 2, it's going to have 2, 3 electrons. So 1, 2, 3. So the goal of all chemistry is for something to have a complete outer energy level. So either boron is going to try gain another 1, 2, 3, 4, 5 to reach this point over here. So that would look like this. It would gain another 5, so it would go 1, 2, 3, 4, 5. And then you can see the outside is completely full. The other option, so let's just say there that that's option number 1. Option 1 is gain 5 electrons. Option 2 is that we rather just get rid of 1, 2, 3 electrons. So just lose 3 electrons. So look at that, 5 and 3. So it's going to be easier to rather lose 3 electrons. So boron would rather lose 3 electrons. Let's just say here, lose and lose. You can say give or lose, doesn't really matter. We're now going to look at carbon. Now here's where things are going to start getting interesting. So let's look at carbon now. Okay, so carbon has a nucleus, of course, which is positive. Well, let's do it in red, and that's positively charged. Carbon is in energy level number 2, or it's in row 2, so it's got 2 energy levels. In the first energy level, it's going to have 2 electrons. And then in energy level number 2, it's going to have 1, 2, 3, 4. So we put them separate. 1, 2, 3, 4. Okay, so now here's where things get super interesting. Carbon could either, option 1, it could rather go this way and gain another 1, 2, 3, 4 electrons. So it could gain another 4. So 1, 2, 3, 4. So that could be option 1. It could gain 4. But the other option is that it could lose 4. 1, 2, 3, 4. It could lose 4 electrons. So what does it do in real life? Well, it can do either. It can go backward, it could lose or gain. So for carbon, it could gain or lose 4 electrons. How cool is that? Okay, now we're going to go on to nitrogen. We're nearly done, and then I'm going to show you something quite interesting. So we're just going to go on to nitrogen now. So nitrogen is it has, let me just see, 7 electrons. So I'm just going to take the carbon and I'm just going to add one more electron. So this was carbon, and then I'm just going to add one more electron. So maybe like that. Okay, so nitrogen is over here. Option 1, it could just gain another 3 electrons. So it goes 1, 2, 3. So that's option 1. It could gain 3 electrons. That would be 1, 2, 3. And then you can see the outer energy level is complete. Option number 2 is it could lose 5. 1, 2, 3, 4, 5. So it could lose 5. Now that's not going to happen because 5 is more than 3. So it's actually going to choose option 1 where it's going to gain 3 electrons. So nitrogen is going to gain 3 electrons. So can you see how when we started on the left-hand side of the periodic table, it was all about losing, 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 losing. Then we got to started getting to this side, and now we're starting to rather see gain or lose, and now it's saying gain. See, so there's something interesting happening here. Now we're going to look at oxygen. So oxygen has 8 electrons, so I'm just going to take the nitrogen and just add one more on the outside. So it would have 6 on the outside, because 1, 2, 3, 4, 5, 6. Okay, so I'm going to go a little bit faster now. What would option 1 be? Option 1 be would that it just adds another 2 electrons. So add 2 electrons, or gain 2 electrons. Let's stick with what we've been saying. It could gain 2 electrons. And then option 2, it could rather go and lose 1, 2, 3, 4, 5, 6 electrons. It could lose 6 electrons. Now that's not going to happen. That's too many. So oxygen would rather gain 2 electrons. And if it did that, it would go like that. Okay, and so now you could see that it has a complete outer energy level. Now we're going to quickly look at fluorine, and then in a few moments we're going to do fluorine, and then I'm going to quickly show you these valency numbers that we used to look at a few lessons ago, and you're going to start understanding what those valency numbers are compared to what we've written down over here. So let's go do fluorine. So fluorine has 9 electrons, so it's got 1 more than oxygen. So I'm just going to quickly fix that up. So that would be, it would have how many on the outside? 1, 2, 3, 4, 5, 6, 7. So 5, 6, 7. So that is what fluorine would do. So option 1, it could just gain 1 electron. So it could just gain 1 electron. So there we go. And then look, it's complete. Option 2 is that it could rather give away all 7. 1, 2, 3, 4, 5, 6, 7. Because then it would be complete as well. So it could lose 7 electrons. But that's not going to happen. That's too difficult to do. So we're rather going to go with option 1, where it will gain 1 electron. Oh, and let's just say a fluorine, gain 1 electron. And then let's just quickly go do neon. I just want to show you something. These are called the noble gases, and they do not react at all because they are already complete. But let me show you why, or let me show you how. So if you look at neon, it's got 10 electrons. So on the outside, it's going to have, it will have 1, 2, 3, 4, 5, 6, 7, 8. So on the outside, it has 8. So look at that. Neon is already complete on the outside. It doesn't need to gain or lose any electrons. So neon did not gain or lose electrons. And that is what noble gases are. They are all of the elements in this group over here. They don't react because they don't need to react. Because the only reason that things react is to be able to have an outer energy level. Okay, so now we're going to make some interesting conclusions. Well, first I wanted to show you something. We're going to look at valency numbers now. If you had to go and do this technique that we did in this lesson for all of these in group 1, don't worry about hydrogen because hydrogen's in the wrong place. But if you had to go do it for lithium, Na, or potassium, you would see that all of them would rather lose 1 electron. So I want you to think about this now. If an atom loses 1 electron, will it become more positive or more negative? It would become more positive. It would become positive by 1. right? Because if you have a nucleus that is positive, and let's say you've got three protons inside your nucleus, and then you've got something like this, and you've got 3 electrons, 1, 2, 3. Then what would the overall charge of this molecule be? Well, it would be completely neutral or 0, because it's got 3 positives and then it's got 3 negatives. But we said that all of these in group 1, if they would like to become complete, they would rather lose 1 electron. So if they lose 1 electron, then there are now 3 positives and 2 negatives. So what would the overall charge become? +1. So we say that these ones have a valency of +1. If you had to go look at anything in group 2, such as beryllium, they would rather lose 2 electrons. After they lose 2 electrons, they would rather become +2. When we looked at boron, we said that it would lose 3 electrons, so it would become +3. But when we looked at carbon, we weren't sure if it should rather gain or lose 4 electrons. So your teachers maybe told you that carbon is actually, for its valency, it'll be plus and minus 4. For nitrogen, it would rather gain 3 electrons. So if an atom gains electrons, it becomes more negative. So it would become negative by 3. Okay, and then for oxygen, it has to gain 2 electrons, so it would become negative by 2. And then for fluorine, if it had to gain electrons, it would gain 1 electron, so it would become negative by 1, because electrons are negative. And so these are the valency numbers that you've seen before, but now you have a better idea of what they actually are. So the valency is an indication of what the atom charge will become when trying to complete the outer energy level. Okay? And so that's really important that you understand all of this. And then the last thing I just want to talk about, and then we're going to end this lesson, is that in general, the metals. Now, it's not a 100% rule, but it's something that you can remember. The metals which are on the left-hand side, all of these guys and some of these ones over here, if you look carefully, what they like to do is they like to lose. They like to lose electrons. So they like to, or give away electrons. Metals give away electrons. And that's just because it's easier for them to give electrons away instead of trying to go and collect electrons. Okay? And then what we noticed on this side was that the things on this side, like N, O, and F, they like to gain. So they are the non-metals. So the non-metals, they like to gain electrons. They like to gain electrons. Okay? So that was a very information-packed lesson. I hope you got most of it and you understood most of the ideas I was trying to get across to you. In the next lesson, we're going to take all of these ideas a little bit further. Thanks for watching.